Hello and welcome to the OCR Further Maths Pure Core videos. This is Vectors 5 Lines and Planes, video 5.2, the perpendicular distance from a point to a line. So in this video we're just going to be looking at what happens in 2D. Later video will show what we do in 3D. And we can see here this formula that we are given in the formula book in order to work this out. You can see that we've got the equation here of the line ax plus by equals c. It needs to be written like that, so you need to make sure you're careful with your signs. Down here we've got something where we simply need to substitute in x1, y1 is a point that we're finding the distance from. Okay, so if we're given this point A, which is the point with coordinates x1, y1, then the distance d that's going to be shortest to this line L is going to be the perpendicular distance. And we're just going to substitute values into this equation that we're given in the formula booklet. Okay, so here's an example. Find the shortest distance from the point 3 minus 2 to the line y equals 2x minus 5. Now if you remember, we need to have our line in the form ax plus by equals c. So we're going to rearrange this to be 2x minus y equals 5. And now we can find each of our values. So a is 2, b is minus 1, c is 5, and x1 is 3, and y1 is minus 2. Now we simply need to substitute these into the formula. So d is going to be a times x1, so 2 times 3, plus b times y1, so minus 1 times minus 2, minus c, and that's all over the square root of 2 squared plus 1 squared. So when we simplify this, we end up with 6 plus 2 minus 5, which gives us 3. And on the bottom, we have 2 squared plus 1 squared. So this is going to be root 5. So the shortest distance from this point to this line is 3 over root 5. There's a neat version there to have a look at. Okay, second example. So we want to find the shortest distance from this point to this line with this equation. Now, firstly, what we're going to need to do is write this as the Cartesian form of this equation rather than the vector form. We have done this in previous videos. So we can rewrite this general point R as xy. So we have xy equals minus 1 plus 4 lambda over 2 plus 3 lambda. And if you remember from previous videos, the aim here is to write both x and y, sorry, lambda in terms of x and y, and then we can set them equal to each other. So if we rearrange this equation here, we get lambda equals x plus 1 over 4. And if we rewrite this one here, we get lambda equals y minus 2 over 3. So the Cartesian equation of the line is x plus 1 over 4 equals y minus 2 over 3. And when we rearrange that, we end up with 3x minus 4y equals minus 11. Now that we have that information, we can once again write down the key parts that we need. So a is 3, b is minus 4, c is minus 11, x1 is 3, and y1 is minus 2. And when we substitute them into the equation, we have 9 plus 8 plus 11 on the top, modulus, because we want the positive part of that because we're looking for an absolute distance, over 5. Now we end up with 28 over 5. Okay, thanks for watching. The next video, this one was about 2D, so the next one will be 5.3, the perpendicular distance from a point to a line in 3D.